Hello everyone, welcome back to Hacking with Stewie. So today we are still looking at Super Robot Wars Z and understanding how Hacking works like usual. The big goal for today is to understand in Ghidra how we can see if a string is referenced using Mips pointers or relative pointers. You'll see that Ghidra is quite helpful to help us understand that. At the same time, we will be also playing and seeing the different menu in Robot Wars and see how much it's similar to the tactical situation menu that was seen last time. So let's see this menu. So it's in Robot Wars. So I'm here and I go on the unit ability and we have different menu. I think this one is overview and there's a unit, there's a like a mech information and there's a weapon where you can select your weapons and stuff. We will look at the overview in here and understand some of these strings, trying to find which function is in Ghidra is used to draw the strings and some backgrounds. And at the same time, we will understand if we have any strings in this screen that are used that are referenced using relative pointers or MIPS pointers. So if we take a screenshot, we can take a screenshot of these stats maybe. And I use my friend, like always, Google Keep. I think at some point maybe Google will start calling me to understand what the hell am I doing. But I took a screenshot and we have a string. Since we already searched for encoded strings in the ELF file in Ghidra, we can go on the define strings tab and try search our string. First thing is we see is there's actually 7 place where this string exists. This is only in the SLPS file, so the ELF file. So there is a 7 place where the exact same string is in the data. And Ghidra found all of these 7 addresses. So somewhere there's one of this address that is used to draw these stats here and for this menu. So we could go and start adding breakpoints and see, trying to find which one will break on read, and we would be able to see which string is used in this menu. But 7 might be actually long to do, so what is easier is this string, the stats for a unit is actually like for a pilot, it's probably used in a lot of menus, so it's probably not a good choice to find a string. It might be better to look at one of these 4 instead. So I will look at, let's say, these 2 and see if maybe we have less. Do we have like less? Where is it? My screen. Sorry, I'm. See if we have less stuff in here, and I'll probably create another one. Because if we have less address to test, it will be easier for us, right? Do we have less address with this? No, we have more, so it's probably not a good choice. So let's keep our basic one that we tried. So it was this one, and we'll just go and add a bunch of breakpoints in our game. So we open our debugger like usual. We can go on the breakpoint stuff, and I have a couple that were used last time. I'll just delete them. And what we want to do, we can, I think we can, easy way, let's see if we can copy paste that address. New breakpoint. Not really. I'll just type it. Let's start with the at the top. There might be easier way. So what we want to do is put a read breakpoint, because if the game is drawing text at some point, it will need to read the text and then get the glyph from the font and draw it on the screen. So for sure it will need to do a read on that address. So let's put one read here. And we see it's actually not breaking. Sometimes it's also good to move from screen, because if you stay on the same screen and you put a read breakpoint, sometimes the code will be only read once the first time the menu is open. So it's good if you can switch and toggle back. I'll put like 2 more, and we'll just continue this until we find the good candidate for us. So if it, let me, it's big, I'll just put it on my second screen so I can add a couple, if you don't mind. F4, 58. Let's do another one. And since I'm already on the screen, I could just continue and see at some point if the game break, I'll see like a run, and it will be the visual will be frozen. So I'll just continue until I see if the game actually wants to break. 108, okay, 44, 19, 28, sorry. Let's see. Nope, not the right one. We seem to have found the right stuff. So we see, so when we put our breakpoint, the instruction as a stop in here, we also see it from the debugger that since it's said run, it stopped, and we see the visuals that stopped here. Debugger has stop on this instruction. So we have LB V0 A0. So this is a load byte instruction. So a load instruction is always reading from an address and reading the value and putting it inside V0. So A0 in that case would be the address from where it reads data, and it will load the content of 1 byte at address A0. And the 0 here means that there's no offset from this address. It's really A0. So if we look at the register in here, we see A0, we have 443820, which is the address that was in here. So 443820. And if we go in here in Ghidra now, we see that our string is here. This is the address of our string. We could actually look at the bytes in the SLPS if we want, and we see that it's probably the one here. So it's 5B, 5A, it's this one. So the string starts right here. And we can go back to the decompiled version. This is something else, I think. So I think we mostly want to look at this. So this string, it's the string we wanted to search. It's referenced by 3 different things, which is nice. So this string referenced by 3 functions. As you see, I already map some of the function. The draw robot tab 1 is actually the first tab in here. So you technically, this information you don't know. Like you would just see a bunch of fun. And first time you do this, you don't really know which function is it. You would just see 3 reference and you don't know which one is it. So let's just say that it's our first time, and debug has just up in here. What you can do is you remove the breakpoint. So I have a bunch. I remove the breakpoint. And what I'll use is the step out function. So right now, we could go at 3a 9770 if we want, just to understand which function is it. Like 3a, it's doing a bunch of things and it's reading something in here, blah blah blah. This is the same as instruction. And this function is called by a lot of things. If we go at the start, there's like a bunch of ref. So what we can do is, if we do step out, it will finish to run the function and exit the function and break just after it exit the function. So we need to remember what's the name of the start of this function. So it's here. Like if I was something here, I go above, lab, it's still in the same function. I go until I find the fun stuff. I already renamed it to prepare line, I guess. But the start of this function is this. So when we do step out, only once, it will go here. So you see just above, we have 3a 96d0, which is the same as the start of this function. So the JAL here is the operation that will call the function that we just. So it exited this function and it went right here. So you might be asking why I didn't go on the line above, because like it's the one that just right after. Main reason is there's something in PS2 and there's a slot. I don't remember the exact name because I'm still a beginner. Every time you have a br branch equal instruction, JAL instruction, the like the Mips assembly, the processor will always, before executing the instruction here, it will always execute the instruction right after. So this instruction is not exactly part of. You could say it's like if the instruction would be just before, because this instruction is run and then it goes inside the function. Something to remember when you debug, because it's part of the things a beginner don't know. So you need to be careful about this. So in that case, when when this function is called, when you will be inside the function, a0 in that case will have the value 80 in x. Because this is add, and I made a mistake in the other video, it's not unsigned integer, it's immediate. Because the immediate add, it take a register and add the value, but you could add another register and it would just be add u instruction. So in that case, it does E3 equals 0 plus 80. So it's the same as setting E3 equal 80. So yeah. So basically it brings us to this instruction. So we can go in Ghidra and see where it is in Ghidra, this address. So 34 B960. And we see we are actually here. And we can, if we want, if we click, it's like a weird function. It does a while, and you can clearly see it's very different from the menu function we had before, because the tactical data, it has a lot of call to function that we're setting x coordinate and y coordinate. And this function, it seems to be very simple and doesn't do a lot. So what you can do in that case, since we see it's very different from the other function, I will just do another step out and see what do we got if we exit this function. So 34 B9 80, and we are here. So again, we are just here. We just finished executing and it went right to this. So 34 BB1C, 34 BB1C, where that is. Okay, interesting. bunch of address stuff. It's good. Still don't really understand what it's doing. And I will do another step out and see. 34, billet 34, c'est 540. Until we get something more interesting, we can do step out. So, and see, can we get to a point where the structure of the function really looks the same? And the answer will be yes. So you see, like I stopped and I'm in this function, and now we see the same pattern with the load graphics. You see setting an address for a string, defining the x and y coordinate, and I like this better because now I see a lot of call with the same function name but different parameter, and it's the same as the draw tactical like the other function. So it's nice. Now I have this, and I like if you do more testing, I can clearly see that it's the draw robot tab one because let's say now what we can do, if we go back, we said it was the 44, 38, 20, if I recall. So we can, if you go down, you see there's a every time there's a function like this, it will try to use a string, and I already put a comment, group of 6 label for stats, so it's right here. Okay, so we found a string and we can do more tests and we can rename the function to something draw robot tab 1 or maybe draw robot overview, something like that. Okay, so now this string that I've just found, it's if we double click on it, we see it's one string that is referenced by 3 different places. So 3 different functions that are referencing the string. When you see the name of a function like this, let's say we go back to draw robot tab 1, double click. It's always using Mips pointers to reference these strings. So we are back at this line. And you see this is the add immediate unsigned part that gives us the address. And like I said, every Mips pointers always come with two part. You have the add part and the load unsigned immediate. So A1, if we middle mouse click, we go back and we have the load immediate. So 44 with a 0, and you add this, you get this. So this is immediate pointers or Mips pointers, like the two are the same. So we go back to our string. We see a string that has a xref with a function. It's Mips pointers. So if you update this string in one place, you will affect tab 1 and tab 2 because this I already mapped tab 2 as well. So we could do a small test. And let's see, we go at 44, 38, 20 just to confirm. 44, 28, 20. So we have our string. It's 2 kanji, so it's 2 bytes for each kanji in ShiftGIS encoding. So we can do something very basic. I know the game doesn't support English. No, the game doesn't support English. So we'll have to let me just confirm. Yeah, okay. So if the game doesn't support English, I cannot type English characters because it won't be able to write it on the screen. So, but just to test, what I can do is just put the same bytes. So the same kanji appears twice. So I would see this kanji twice. So we are still in debug mode because even if we remove the pointers and do a bunch of step out, it's still stop at one instruction. So we just need to re-click on run again and go back and we see our string that has the same kanji twice, and the second tab will have something similar. And it's probably here, you see. So it seems to work. Updated one string and we get the, I guess I changed, we get the same result on both screen. Now let's see how a relative pointer are referenced in Ghidra, because a function like this, it's Mips, and we can move and see this one. Okay, we have a couple here. So I'm not sure, I don't think it's in the same menu, but this one is good. Okay, so I believe this string is one that appears at the top in the menu. So let's go back. I believe it's this one. So one string that is referenced by the same function but two different places. And we have this thing. So this is how you know it's referenced by relative pointers. If you double click on this, so the address of the string is 443798. This is the address in memory. So if I take this and go, we will find our string in memory view like we did. Boom, we have our string in here, blah, and it ends here. So when you double click on the small number in here, you get something like this. Pointer something stuff with a bunch of address, blah, 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 and you have the string here. This is like a small pointer table basically that starts at 42E5F0, and you see a bunch of stuff in here. If you go on the there's no code assigned to that because it's just data. It's not Mips code. But you can go in the bytes and you would see how it actually look inside the SLPS file. So clicking on it again, I see it's at the top and it's here. Now that's the interesting part. So this is the first in the series, which is 4 bytes, and you have second one, third, and fourth. Then you have a bunch of stuff that is used by something else. Maybe it's code, but this is not a pointer. How do I know it's a relative pointer? It's because this is an address that is in Little Indian. So if you take 443798, you will get this address, 443798. And if I double click, it's this string. So this is telling me in memory at this address, you have the pointer table. I could test it and go in memory view because this is the memory address. So in RAM, you can go and see, and I have my pointer. So we have 4 pointers, and usually on PS2 pointer, it's always on 4 bytes, and it's usually Little Endian from what games I tested so far. So this is the pointer in memory, and if you follow previous video, we know we can get back to the where is this pointer inside the file itself. So we can something we can do relatively easily is to just open the SLPS file in our X editor. We can just search for it. 98, 37, 44. I already forgot it. I'm very bad. Yeah, 98, 37, okay. 98. And I can do search direction all and see how many match I have, and I only have one. So we could have more than one because the same string could be referenced by 4 relative pointers. So it's right here. So we know if we change some stuff, if we change the translation, and maybe let's say the string is now longer and it moved location, we will need to update this pointer as well. changing this string would also mean we need to adjust all the other pointers that are referenced. So not only the relative pointer, but all the Mips pointers. So this is a more complex part where the same string is referenced by multiple pointers, and it's how it looks in the code. Technically, we could have another type of, like not other type of pointers, but okay, like this, you see. One string, yeah, I guess you could have a, is it ready? Okay. Not exactly what I wanted to see. Meh. But yeah, you could have the same string referenced by more than one pointer, and it's the really fun. So this is cool because you can actually find many pointers table using Ghidra if you look for these PTR. And when you double click, you can find the start, and so it's nice. And then you can make a script and extract all pointers for this section, blah blah blah, and then you have a bunch of stuff that you don't need. So this would be one section that you extract maybe, and then you categorize the string. So that's what I wanted to do in this session. So understanding how Mips pointers and relative pointers are used in Ghidra, so that you better understand the difference and how it's used inside the Mips PS2. So hope you have a nice day, and if there's anything you would like me to look into or show you how to do, I can do my best and try to explain concepts. So let me know in the comments on that. Have a great day, everyone.